When the Trinus Kodama was presented, it focused on a hassle-free start in 3D printing, seeking pure accuracy. The chassis delivered, but the electronics, well, not so much. The machine's brain was an ATmega 2560 paired with Allegro A4988 drivers on a bespoke PCB by Panowin. It was the current and mainstream 8-bit setup that soon would hit a wall. The issue? The lead screws. These guys just chuck steps per millimeter like nothing else. With such a high resolution, the 8-bit processor simply couldn't keep up with the step per pulse frequency required for high-speed travel. It was just literally suffocating the machine's capability. Enter the MKS skipper. In this series, I'm upgrading the Kodama to current gen electronics and firmware, going for a closed-loop flavor with the MKS Servo 42Cs. We're jumping from a struggling 80MB to a 64-bit architecture capable of driving Klipper without breaking a sweat. But before we dive into all this, I think we should perform a minor checkup on the hardware to see if the chassis can really handle the speed. Having waked the extruder assembly and doing some basic math on the LED screw's efficiency, the theoretical limits are, well, let's say mildly interesting. But in the end, with the stock chassis, we'll just set some safe numbers as a starting point. 30,000 mm/second square acceleration and 25 mm/second V-jerk. Now, in order to get some more room to print motifs, I moved the C steppers to the top of the column using some printed spacers to lift the set. For the X and Y axis, I swapped the stock motors for some bigger ones, but they had these AliExpress special cast aluminum end caps. Since I don't do half-ass jobs here, I took them apart and swapped the original Panowin covers onto the high torque stators. I'll solve the clearance issues later, assuming it stays bolted together. The new setup is centered around a lightweight VQ extruder unit paired with an MA14 motor. It's about 250 grams, like half kilo less. So we'll see how that plays out with the math. Anyhow, the closed loop control PCB I'm using is designed for NEMA 17 footprints. So yeah, see the problem? Oh well. So I fired up FreeCAD and set out to design a quick fix in 10 minutes. The Rebel style hot end will do the trick to keep things light. So, the hardware is finally sorted, and the aesthetics are, well, you decide, just comment below. But now comes the real challenge, cramming 10 pounds of electronics into this tiny case and teaching a 64-bit brain how to drive this 2016 tank without shaking it into a pile of scrap metal. Next, I'll be diving into cable management hell and firing up Klipper to see if my math actually holds water, or if I just built a very expensive desk ornament. So stick around to see if this thing actually prints or it just looks for maximum entropy. Catch you in the next one.